All right, so this video is to explain how to do the extra problem that I assigned you guys for section 4, chapter 7. So you have this premise here that you have nicotine with a certain formula. That's a weird looking formula because that X, Y, and Z are just unknown numbers. So I have to find whole numbers to fill in for those values. So I'm supposed to determine the composition. I have this information. I know that I'm going to produce, when I burn that nicotine, 1 mole of carbon dioxide, 0.7 moles of water, and zero point 0.2 moles of nitrogen dioxide. So I know a couple different routes that I could take to do this. But the reason why it bugs you guys is because you see this and you're trying to think about doing empirical formulas, and you want to change these values 1, 0.7, and 0.2 into moles, but they're already moles, right? So you should understand what you're supposed to do. If you have mole values, you just start doing ratios at this point, usually, right? Now, this problem is a little bit weird because this is a compound, carbon dioxide, and I only care about the carbon in that carbon dioxide, right? So in this case, nothing changes because if I have 1 mole of carbon dioxide, I still have 1 mole of carbon. But in the second one, when there's 0.7 moles of water, there are 2 hydrogens in a water. So I actually have to double that 0.7 to make it 1.4 moles of hydrogen, right? And then that last one, there's 1 nitrogen and nitrogen dioxide, so it stays the same. It should still be 0.20, right, in terms of the nitrogen. But these are all mole values, so all I have to do is divide by the smallest. If I take 1 and divide it by 0.2, right, I don't know where that extra decimal came from, sorry, I get 5. If I take 1.4 and I divide it by 0.20, I'm going to get a 7. If I take 0.20 and divide it by 0.20, I'm going to get a 1. So that means that my empirical formula should be C5, H7, and 1, right? So then I just have to look at the rest of the problem to find out if I did that correctly. Because I'm supposed to know also that the formula mass for this stuff is going to be somewhere between 150 and 180. So down at the bottom it tells you that. So I need to know what the mass of this is. I can do that, and I don't really need to be very precise here because it didn't tell me a formula mass that was very precise. It said it was between 2 values. So I'm just going to do this kind of short. 5 times 12 for the carbon would be 60, right? And then I have 7 for the hydrogens, and then I have 14 for the nitrogen. So I know it would be like 60.05 and 7.07, but I don't really care about the decimals because it's not going to matter. So I add this up and I get 81, right? And I'm supposed to be finding something that's between 150 and 180. Now, 81 is not in between those two things, but I'm pretty sure I could double it, and then it would be in between those two things, because then it would be a 162. So that just means that I need to unreduce my empirical formula, and my equation will probably be, or excuse me, my formula will probably be C10, H14, and 2. And it turns out that would be correct, right? So you can look up nicotine and find out that that's exactly the formula that it would have. Again, this is just a chemistry problem. I'm not encouraging you guys to burn nicotine, but understand that that happens, right? So we need to know what is made when it's all said and done. Just a chemistry problem. Don't smoke. But again, there is another route to this, another way that I can do this, and it involves actually using those original amounts in a different way. So if I think about this differently, I should know that a combustion would look kind of like this. H, Y, and Z, right? I didn't know what those values were, but I could find them out in a different way. So I combust with oxygen. You just combine every element in that nicotine with oxygen to make some stable product, which would be the carbon dioxide, the water, and then that nitrogen dioxide. Right, so it's just everything mixed with oxygen. I can essentially ignore this oxygen amount here because I'm not balancing for real, but I want to know what whole number values would go here, here, and here, because that could help me find x, y, and z. So it's really kind of the same idea, it's just a different way to do it. So if I start out with that 1.0 and the 0.7 and the 0.2, I could also recognize that, okay, what if I just made these whole numbers, right? What if these were the values that I got that don't end nicely because 0.7, 0.2 are not whole numbers, but one's a whole number, right? I could also, from the get-go, just start multiplying to get whole number values, right? So I might see this 0.2 and recognize, oh, I can take that times 5, right? So then I take everything times 5, right? So I get a 5, 7 times 5 is 35, so that'd be 3.5. And then this is a 1, right? But then I recognize my 0.5. Oh, from the beginning, maybe I could have just multiplied by 10 because that 0.7 is not a whole number, but I'm pretty sure if you multiply any 10th by 10, you get a whole number, right? But, oh well, didn't notice it, but I can multiply by 2 now. And now I have a 2, and I have a 7, and I have a 10, right? Which should be my values for whole numbers here, here, and here. But then I just have to recognize that if I'm going to balance, right, X has to be 10 because there's 1 carbon per carbon dioxide, right? Y has to be 14 because there are 14 hydrogens in 7 waters, right? And then the Z value has to be a 2, right? So I end up with the exact same formula, C10, H14, and 2. That should be the same thing I had over here, right? So really you could pick either way to do it. I kind of like the first method better personally, but both things work. So you can go either way, you just have to understand what you're doing exactly to get that answer.